Yo, Garrett, it's like, do you think a deer knows it's a deer?
Oh.
When a deer sees another deer in the woods, does he know he's a deer? Like, there's no mirrors in the woods, so how would that deer know he's also a deer?
Oh no. Did you see that?
No, see what, yeah? What is that? It's some weird language. I can't read it.
It's upside down.
Yeah. What?
Somebody's got a plan to nuke Tom's River?
Dude, we gotta stop this.
Alright, meet me at my house in 30 minutes.
Alright. So, how are we gonna do this?
Time travel.
Time travel.
Yes, time travel.
So, how do you suppose we do that?
With this watch. You set the time as the date.
I guess that's believable, but, like, what are we gonna do when we get back in time?
We're gonna stop the scientists from making the atomic theory.
Alright, let me get the rundown.
Alright, first up, we got Democritus, year 465 BC. He hypothesized that atoms cannot be destroyed. They differ in size, shape, and temperature, are always moving, and are invisible. What I'm hoping that happens is that when we appear out of thin air, he gets so confused that everyone thinks he's crazy, basically, and that no one believes him anymore.
Seems pretty easy. So, next is Aristotle, right?
Yep.
Oh yeah, Aristotle. He believed that everything was made up of 4 elements: fire, water, earth, and air. So that's wrong in the first place. So let's just let everybody believe that.
Sounds good. Next we got Robert Boyle, year 1650. He stressed the organization of atoms.
So we should just unorganize his atoms. Right.
I guess. Yeah. Would work.
Who's next?
Next we got Antoine Lavoisier. From the year 1770, he created the law of conservation, which stated that matter cannot be made or destroyed. He also hints at the rearrangement of matter and reactions. Matter rearranged but never disappeared.
So we should just make matter disappear in front of his eyes. Next is Joseph Krauss, 1790, and he stated the law of definitive proportions, which the law states that the ratio of elements in the compound is always the same or consistent.
So we're just going to throw fruit salad in his face and show him that compounds aren't consistent.
Exactly.
Up next, we got John Dalton.
Goddamn John Dalton.
You know what John Dalton did?
Did I know what John Dalton did? No.
Oh.
I don't. Right.
Well, John Dalton had his own theory, that matter is composed of extremely small particles called atoms. Atoms are indivisible and indestructible. Atoms of a given element are identical in size, mass, and chemical properties. Atoms of specific elements are different than those of the elements in a chemical reaction. Atoms separate, combine, and or rearrange.
So we just have to steal his theory so he's nothing to work off of.
Up next, we got Michael Faraday, year 1822. He studied the effect of electricity on solutions, coined the term electrolysis as a splitting of molecules with electricity, developed laws of electrolysis. So we have to shock him so he gets scared of electricity.
Alright.
And that way he never uses it again.
Alright, that seems pretty easy. So all we have to worry about is J.J. Thomson. He's the man who discovered the electron by making a cathode ray. So we should just steal that, and that'd be it.
Sounds like a plan.
Alright, too sweet.
Too sweet. Ready to go back in time?
Alright, we just have to watch the 442 BC. Alright. Let's do it. Alright, this is 442 BC. This is where Democritus figured out that matter cannot be created or destroyed.
There he is.
Alright, let's get him. Alright, now that he's out of the way, we can move on to Robert Boyle.
What about Aristotle?
His theory was wrong anyway, so we don't have to do anything about him. So
Sounds good.
we can go to, what was it, 1659, see what Robert Boyle's up to. Alright.
Alright, we're in 1659 right now.
Alright.
And this is when Robert Boyle stressed the organization of atoms.
So let's not organize his atoms. There he is now, right?
Chris, help, it didn't work. God, the science. Let's see what Antoine Lavoisier is doing in 1772.
Alright. Thanks, dude. Alright, let's find Antoine, who created a law of conservation, which said that matter cannot be created or destroyed.
Let's destroy some matter.
Yo, Antoine, watch this. My theory was wrong! Alright, we have to get Joseph Proust next in 1794.
Alright. So, Joseph Proust, he stated the law of definite proportions, which says that the ratio of elements in a compound stays the same.
Alright, well, so we should just get a bowl of fruit salad, right? Just throw it out and we'd be like, consistency's dumb. Oh, science, right?
Sounds good.
Yo, Proust, look at this.
I guess compounds are inconsistent.
Next, got John Dalton, 1803. Alright, ready? Alright, we're here in 1803. Well, John Dalton has his whole big theory that no one really remembers, so we're just going to take that theory off his desk so he's nothing to work off of.
Let's do it.
Alright, let's go.
Give me that. I have to travel to Michael Faraday in 1832.
Let me wind it up. Alright, this is the year Michael Faraday discovered the splitting of molecules using electricity.
Alright, so we'll just give him an electric shock and he'll never use electricity again.
Alright. Wait, what, Michael?
Alright, the last scientist we got to deal with, J.J. Thomson in 1897.
Alright. Alright, this is J.J. Thomson. He discovered the electron by using the cathode ray.
So it looks like we got to steal it then.
Alright, let's take it. Alright, time to go home. Alright, 2015, home sweet home.
Let's go back to the woods, see if the plan worked.
Alright. Yo, there's the bottle, there's the bottle.
Devil log.
Shit. It's a letter. It's from our future, dear future Chris and Garrett. The plan went wrong. Since the atomic theory wasn't discovered, America never dropped the atomic bomb to Japan. So Japan fought back, defeating America and aiding Germany too in World War II. Now America's under German control. Love past Chris and Garrett. P.S. The doc's still alive.
The doc's still alive?
Doc's still up.